Hi, I'm Marina from Amplify, and thank you for your interest for the topic. Probably most of you have already tried some development with large language models. I'll call it LLMs for shorten, even though it should not necessarily be language models, could be any large intelligent models. Or maybe you just try to play with ChatGPT as a user, and it could go pretty exciting or disappointing, or maybe even scare, like Miroslav just showed us. So today I offer you my point of view on the development of such smart applications. I am a data scientist, and I see from my side quite some good and bad patterns what we usually do when we develop such an application. So I collected these do's and don'ts, and I hope you will be a bit better in development such application and the half of the hours. So I have over a decade of experience in development smart applications, starting from my PhD study with application in medicine, cybersecurity, industry, energy sector, and so on. And release of ChatGPT bring me some idea that we can do way more better for non-technical people to make their life, their daily job, way more easier. So I became a happy amplifier. And in Amplify, we created a tool that allows companies to communicate with to listen from their customers and communicate fluently. In Czech Republic, this company mostly known as former social bakers. And now we have offices all over the world. And in 2022, our company became a unicorn company. So my team calls innovation. And we are the most gardeners who plant the seed of ML and AI almost in every solution that we produce. From business perspective, we can split this task that we are working on, generative and analytical. It's quite vague division because every generative task requires some thinking from the model, and every analytical assumes some generation, of course. Even though Gen AI hit us all dramatically, I would say, most of the business use cases are still analytical and require analysis of a big amount of the data. We have been developing such application for last 3 years, so we have some good and bad practices in our experience. And today I'm going to share it from our side what works for us and what doesn't. I would like to start with some bad practices because we just learn from the mistakes. Then I will discuss some better approach, how can we solve these problems and which benefits it gives us, like a systematic approach for design, wise use of LLMs, and evaluation. So let's start with something that could go wrong. So first of all, hype in the LLM gives us an illusion that LLM is really capable and can do literally everything. From this point, we start to use an LLM for everything, even then when we don't need it actually, even when classical, traditional, let's say, algorithms work better for this, like parsing, formatting, masking, and so on. So And as a data scientist, I see that we forget about the golden rule, garbage in, garbage out. So first, we don't put much attention to the data, what we actually send to LLM for analysis. And noisy data create long prompt, and it just flood the prompt with some unnecessary information, which of course lead us to some inconsistent, unclear completion from the LLM. And another problem that I can see that it's lack of experiment. We just try to do something really fast, deliver really fast, and not pay attention to try to see how it will work in different situations that from the perfect way. This one. Second is monolithic design. So once we decide that our model is so great that it can do everything, anything, all at once, it became one big black box. The problem with one big black box, probably you all know about this, it's so model should be first way bigger than probably necessary for us, because it should follow a long construction. So it should be big context windows and model big. Big model is greedy for resources. Monolithic design, by definition, is limited on adaptability. So changing in some small part in prompt, let's say, or in data, leads to changes of everything because of how the connection in neural networks naturally works. Then it gives us some long instruction, and long instruction could be inconsistent. If you remember some old funny video, draw me red lines, some with green inks, and some should be transparent. So sometimes prompt could be really that confusing, even for human, and LLM get lost at this absolutely, and never say there's something wrong, that will try to do these things. And of course, it when something goes wrong and we have this one big monolithic stuff, it's really hard to understand what actually went wrong, and we can't actually have the validation that this particular part brings us this problem. And this brings us to the situation when it is lack of evaluation and validation. So we try something, and it seems work. It just seems work. And under this, we don't know how actually good it is. And if we don't have this evaluation approach, we don't know metrics, we cannot compare different solutions, because how do we say it's better or not? How do we say it could fail in some certain situation? This also brings this not good practice, ignoring hallucinations. LLM hallucinate. It's naturally what it does, literally. It creates stuff out of nothing almost. So you need to keep in mind that it could happen. So really think about this. And last and probably most important stuff, it's safety. Something that also Miroslav showed us. This prompt injection stuff, when user can put some malicious instruction inside of the input, or this malicious instruction also can come from the data, for instance. It's really big theme, a big topic. I would say that it was separate topic, a separate talk, and I have no time for this. So here's the link to the Berkeley AI research about the prompt injection. And if you're interested in this, you can scan this QR code and go deeper in the details. One thing I would like to say here, if you consider your model with LLM will work with human, so you need to think about some layer in between. So at least even like simple regex could catch some really dangerous stuff from the prompt or data. Okay, and now we can go to the good part, switch to the good part. Once we decide that our projects require more complicated solutions, not like one simple task from LLM, we start thinking about the application as a system, where LLM is just part of this system. And again, the group from Berkeley, AI research group, has a really nice analysis on compound system for LLM. Actually, modern LLM, like reasoning LLMs, are compound system by their own. That's why they can actually think or imitate the thinking. The benefit that we have from this approach on system design comes to the idea that system is scalable. So changing agent functionality and so on, it's not affected the whole system. It's just one small module that allows you to extend the functionality of your entire application. Second, a system can be dynamic. Especially, it's really important if you creating some knowledge-based system, for instance, retrieval augmented generator. If your knowledge are really dynamic, change often, it's way easier to, like, it still requires some efforts from you, like vectorization and re-ranking, but it is not comparable to what you need to do in order to put this new knowledge to the model with fine-tuning, for instance. And of course, since it's modular, you can check each model separately, so it brings you more control and trust to the system. And here comes structured analysis and design technique, old but still good. So this is an approach that allows you to build the application just like you build from the Lego, for instance. You create some separate models, and then you just connect them all together. The key components of this approach is function, basically what your model should do. Input and output, quite self-explainable. Control, some rules, some limitations, what it should be. And mechanism, tools that you're going to use to achieve the result. I would like to talk about a bit in the example about this. My recent project, one of my recent projects was about the extraction, the topics from the shopper's review for e-commerce platform. Imagine you would like to buy a new camera and make shots from your bestie first marathon run. So you go to the web page of the e-shop and you would like to read what actually people are talking about. But you don't want to read all the reviews. You would like to specify it like for sport photography. So the task is to extract these topics from the reviews. And for our scheme, it looks like this. So input is reviews, output is topics. As a control, we have some rules, some requirements, how this topic should look like. So it should be about the product. It should not contain some brands, special brands, for instance, because it's obvious. Or human emotion, which is quite often appears in the reviews, like I like it, I don't like it, it's amazing, and so on. And little tools like some libraries that we can use for achieve this. Then we decompose this task to some smaller task, and each of them could be decomposed further to the really atomic stuff. For our use cases, include some text preprocessing, some really common NLP practice, some analysis, which is language, which is sentiment, statistic of the keywords, and so on. And then we need to make some enhancement because usually it contains some similar words, and we don't need them. We don't want them in the results. Okay, let's go next. So we start thinking about tools here, and our first idea was just to put it to LLM, and actually it really worked quite nice. It could follow some instruction, and the results are there. It's great. But when we scale it for the big data, in our case, it's over 200 millions of records, and it's growing number of the reviews. It become really nearly unfeasible because it really takes some longer time, and it's pricey. Even if you have your in-house model, it still requires some cost for computational resources. It's hard to scale actually for bigger customers because it's not one e-shop. It could be hundreds or thousands of these shops, and we have low control and hallucination and everything that I mentioned before. So we start to think about how to scale it to the big data. We did not invent any wheel here and just go with some classical distributed computer tools that works perfectly for this preprocessing. Next, we start to think how to actually extract the topics. We tried several classical NLP tools for keyword extraction. None of them were great, actually, but one was quite promising. It's called Yake, yet another keyword extraction. It's a statistical tool that allows to extract topics way more faster and something that looks like topics at least. And at the end, we decided to use LLM for this particular part. So Yake generates us some candidate topics, and we use LLMs to make them nicer, to get rid of synonyms and so on. So therefore, we solve some key issues, like it's scalable. We have topics that are really in reviews because it's statistically extracted from the text, and simple task for LLM, which is easier to control and way more cheaper for computation. I have lack of time, and I go really fast on this. LLM is a tool, so you need to use proper settings to make it work. You should define, at the beginning, you should define what actually you would like to do. If you would like to use it for more creative tasks, you use parameters that allows your model to generate more diverse result, let's say. And for this, you use temperature and top P. If you need the result more deterministic, you just move it to closer to 0. Quite obvious, like output, it should be short or long. Next is token repetition. I don't want to spend there more time because I run out of time. Sorry. So prompts. If you would like to know more about the prompt engineering, really good practices, please go to this prompting guide and find them there. I just wanted to share some less obvious thing here, like, for instance, beginning of the prompt considers LLM like more important. It's the way how attention head works actually. So it brings you this limitation. Also, some human touch, some emotions put force model to try harder actually. And another quite nice thing to prompt engineering, don't write it by your own. Maybe it's better to describe the task to LLM and then let it create this prompt and let it correct this. Not like pushing what's wrong with this, like you are a useless piece of silicon stuff, so you just need to like let it be patient and let it self-correct itself. So, and at the end, you will be really rewarded for this. Okay, and connected to this, use more agentic workflow. When you allow LLM not just to do everything at once, but do it like repeatedly. One it's generated, and the second it's like a loop that correct this. Is it okay? Is it not? And this will really reduce the rate of hallucination in your in your results. Okay, so using LLM wisely, good prompt engineering brings you some benefits like more trustful results. It's better in performance because you don't use big model for some small task, and smaller model work faster, obviously. Better control on some iteration. You can check if every step go well in this case, and some specialization, like one model, one prompt for one particular part of your task. So important part is evaluation. And I have 5 minutes left. Great. So in my case, it was quite simple tasks when we have determined list of topics, and we just need to compare if the output from the LLM somehow connected to the candidate topics. And in the simple case, when you have something to compare, like one output and other output, like your output and something that you would like to have, it's like you can use some traditional metrics like blue, rouge, meteor, or bird score. For more complicated tasks, I suggest we have like really great experience with LLM as a judge. It's not so obvious. You can use it just, like let decide LLM to say, okay, which output is better, this on that. Or, and the key hint here is not to use the same model or the same prompt. Use different models and different prompts and see how it operates. Also, the same way as you create prompts with LLMs, like when LLM gives you some ideas how to write the prompt, proper prompt, you can use this. You can use LLMs to discover some rules, what completion is good and what is not. You need to create some training set. It may be really small, like, I don't know, 20 examples, which is you as a human label good or bad. Then ask LLM to create some rules for this labeling. And after this, you will have some really criteria for LLM, which is LLM as a judge, which completions are good and why. and this really help you. So at the end, some takeaways, and not repeat myself. I would like you to remember only 3 things out of this. First, don't overestimate LLM. Like, really, don't. Don't forget data science golden rule. Really, check your data, estimate your prompts, and like garbage in, garbage out. It's still there. And the last thing, like really important, is evaluate. Like even simple evaluation will help you to get rid of most of the problem which could come with LLM. So thank you. That's all for me, and I hope we have some time for the questions. Questions? No? Yes, please.
In your methodology, there was a lot of focus on the reviews and the input of the reviews. I was wondering, what did you find in your creation of those rules? So you said sometimes you might find rules. How did those, when you found those rules, how did you apply them?
Mm-hmm. So the question is how to apply the rules that LLM can find during the LLM as a judge cycle. So this rules is basic criteria how LLM should estimate to judge whether the input is good or output is good or not. And not just like score from 1 to 5, but really criteria like why it is so why you estimate. Like imagine as a teacher should make the grade in some test for kids. So it's like really some set of checklists. Like okay, this is concise text. This is clear. This not too vague, and so on. And this will work for you. Yes, please.
I wanted to ask about the evaluation.
Sorry.
Specifically, I wanted to ask about the evaluation.
Mm-hmm.
Specifically, how you dealt with unstructured data when it came to evaluating the outputs of the model.
So the question is how to deal with unstructured data, but how to deal with unstructured data in this project. So as I said, this project is quite simple for evaluation because you have a list of the candidates that we have you get from the statistic, and your goal is to our goal was to evaluate if this list of generated topics does not contain the similar word, like really close synonyms, and if it's not hallucinated, like if it not offers something that is not in this list of the candidates. So it's not like really unstructured data, not that unstructured data in this case. Yes, please.
Could you give us some example of a task where you surprised that after that evaluation it did very well, or it did very poorly?
So the question is to give some example when the after evaluation model went well.
Or very poorly compared to your original expectation.
Okay. Or very poorly compared to the expectation. Okay. Well, Well, at the beginning, it was really quite surprisingly good when we tried to use LLMs for some task. Like really, we tried just to throw there whatever and see how it will behave. And the evaluation of this was surprisingly good. Like really, this could be done with this. As we start with these topics, we just throw there like 1,000 of the reviews and then see that it works. By this, we just again ask LLMs like, okay, could you estimate if these given topics are somehow really could be used for our purpose for the LLM? And back then, it was just a binary match, like is it good or bad? And for bad, usually, it was not so great when you start to try it in the bigger data set with from different domains. It started to become like less obvious. For instance, for this project, when we does it for some technical web e-shops, it was really easy. And when you go to some, let's say, cosmetics, makeup stuff, it is more complicated for the model to get these ideas. Thank you. Mm-hmm.
Do you think this would, so I was looking at this and thinking to myself about the ingestion experience. So you have, in this model, you showed a very short, like a very small data set. Was your expectation to increase the size of the data set that you were evaluating against? And what were your expectations for that pipeline? So this seemed like you were looking to do this over a very large data set. Mm-hmm. And I was wondering what the expectation was for that large. What's the how large a data set are you expecting to be able to do this over?
Well, we start. The question is how big was our expectation for this particular project with topics at the matter of data. So at the really beginning, we knew that we have this over 200 million records, and it was in the requirement that it should be somehow scalable. Thank you.